2023 is going to be exciting for the Ethereum community, especially ETH stakers who have been waiting to realize the actual earnings. If you are interested in learning about withdrawal-centered Shapella upgrade, continue listening. Welcome to PEEPanEIP episode 97. I'm Pooja Ranjan here with a network upgrade special episode with two very special guests from Ethereum Foundation. Today, we will learn about the progress made on Shanghai and Capella testnet, tooling and roadmap. Shanghai and Capella, together known as Shapella, is the next planned Ethereum upgrade. To provide an overview on the topic, we are joined by testing team legends Parithosh and Mario Vega. Welcome to the show, Pari and Mario.
Thank you so much for having us.
Thank you. Thank you so much.
Well, we are here to learn about the testnet updates. We will also love to hear a little background of the guests and how they made their way to the Ethereum community. So if that's okay, maybe we can begin with an introduction of Mario, followed by a brief one from Parithosh.
Yeah, of course. So yeah, my name is Mario. I'm a computer programmer from Mexico. Currently, I'm working as a test engineer for the Ethereum Foundation, and my main job is to basically test all the common upgrades for Ethereum. I've been working for the Ethereum Foundation for the past year and a half, so I participated on the merge testing quite a lot, and yeah, we're following up with testing for Shanghai and all the upcoming Ethereum upgrades.
Awesome.
Hey, I'm Parithosh. I'm a DevOps engineer at the Ethereum Foundation, and I joined something like 2 years ago at this point. I used to work in the DevOps field at a different blockchain company, and one day I kind of saw a tweet that Justin was hiring for a new team, so keep up on Twitter. I think it helps. So I just emailed him about the position and interviewed, and 2 years later, I'm here. I mainly help with setting up testnets and coordinating between client teams for whatever needs to happen for the next fork.
Awesome. It is always interesting to learn about developers' background or people who are always contributing. I think that's encouraging, and people who are willing to contribute to the ecosystem may come forward. Thank you for that. And now, without further ado, let's peep in.
So yeah, our names are Mario and Parithosh. So we are going to present a little bit about how the Shanghai Capella efforts for testing are going at the moment, mainly on testnets and the devnets and all other testing frameworks that we have. So yeah, I think the first thing that we are going to cover is what enhancements and upgrades are included in this new upgrade. And there are different flavors of improvements included. So the first one is how the EVM on the execution layer is updated with this fork. And we have three important upgrades, which is warm Coinbase, and the push zero instruction, and the limit and meter init code, which is a prerequisite for the EVM object format that will come later on another upgrade. And basically, these are upgrades to make everything less gas intensive in some aspects of the smart contracts. For example, warm Coinbase is going to be a little enhancement that makes the producer of the block have his account already loaded into the context, so it will be cheaper for them to do transactions in their same block. And the push zero instruction is basically an enhancement to make cheaper stack operations in the EVM. Basically, this is an operation that happens a lot. We use the number zero a lot, so the push zero instruction is just something that has been missing from the EVM for a long time, and now it's going to be included. And the limit and meter init code is basically just limiting how big the init code or the initialization code for the smart contracts it can be. And we have also upgrades to the consensus layer and somewhere in between. The most important one is the staking withdrawals. This is an upgrade to both the Beacon chain and the execution layer. So basically, this is an upgrade of the interaction. We are finally going to have withdrawals from the balances of the exceeding balances or of full balances from the Beacon chain into the execution layer. And I will talk a little more about this a little bit after. And also, there's an important upgrade to the Beacon chain, which is the BLS to execution withdrawal credential updates, which is a necessary update to be able to tell from the Beacon chain to the execution layer where is going to this where the staking balance of the validator is going to end up in the execution layer. Some changes that have been postponed tentatively to the next fork are proto-bank sharding, which is a very important upgrade that will allow blocks into the Ethereum network to be easily verified and will allow a lot of upgrades and have better gas consumption for the optimistic rollups and for the secret rollups. And also the EVM object format, which is basically the next iteration of the EVM, how the bytecode in the smart contract is laid out, basically. So yeah, the key changes, and I think the most important change for everyone is the withdrawals. We have two kinds of withdrawals, the full and partial withdrawals, which is basically something that is translated from the Beacon chain, from a balance on the Beacon chain of the validator there, into an account into the execution layer. It's basically just moving Ether from the Beacon chain to the execution layer, where it can be moved, spent, or do whatever the validators want to do it. So the two kinds are, we have full withdrawals and partial withdrawals. The partial withdrawals are basically something that will happen automatically for the validators. So if you have been validating for whatever amount of time you have been online testing, participating in the same committee and proposing blocks, you potentially have a positive balance in your account, in your validator account. So with the partial withdrawals, what will happen is that the excess amount over the 32 ETH that you have will be automatically pushed for you into the execution layer. So that excess, which is not being used right now, can now be used. And it can be spent in whatever form you want. You can actually interact now using that excess balance, or maybe even submit a new validator if you have enough partial balance. And also the full withdrawals, which is basically the operation of removing the entire balance from your validator into the execution layer chain. The entire 32 ETH plus the excess will be available for the validators that have already stopped validating. This is in the case of a voluntary exit or slashing. Either way, your entire balance will be brought back into the execution layer. And for that to happen, there needs to be the credential upgrade, which is an important part of the upgrade. And basically, what we have right now on the Beacon chain are BLS credentials, which do not point to anywhere in the execution chain. So the way that a validator can tell the Beacon chain where they want their balance to end up in the execution chain is via a credential upgrade, which will be a one-time operation. And in this operation, the validator can tell the Beacon chain the address of the execution account where the balance should end up in. And this can be either an externally owned account, just like a wallet, or preferably a hardware wallet or a cold storage wallet, or it can be a smart contract. Wherever the validator needs their balance to end up, this is the way that is going to happen. Another important part of this fork is that historically the forks have been triggered on the execution layer by block height. For example, on London and Briar, we had on block 1 million, the execution layer will operate to this new consensus mechanism or whatever. And also on the merge, we had another different kind of upgrade, which was done by total difficulty. And this was done because of security reasons. And yeah, these were the only two upgrade mechanisms. But now we have a third one, which is by time, because the beacon chain always knows what the time is. Now we can use this information on the execution layer to also upgrade. And this is particularly important because on this specific upgrade is the first time that we have to upgrade at the very same time. Starting from Shanghai and Capella, we have to have coordination between the beacon clients and the execution clients, because if the beacon chain upgrades, but not the execution layer, it will be possible to, for example, the beacon chain to tell the execution layer to withdraw something, but if the execution chain has not upgraded, it will not know what to do. So it's very important to keep this upgrade in sync, and this is something that has to be tested also very thoroughly. Another change is on the execution layer. We now have a new field on the blocks. So the blocks, we will now have the list of withdrawal that happened on that specific block, which is something that's necessary because otherwise you could not sync the execution layer clients if you don't know what the balances how the balances were accrued on these withdrawals. And this is also important because you can also prove that a certain withdrawal happened, and you can prove it inside of a smart contract by having the block header hash and all that sort of stuff. So it's very important to have this information also. And also, yeah, as I already mentioned, the smart contract initialization code is now limited, which is a prerequisite for the EOF, which is an upcoming fork. So yeah, there are a lot of challenges to test on this upgrade. And one of the most important challenges to test is that the withdrawals are only initiated from the beacon chain. This information that only the beacon chain has, because they have the state of the validator, they know all the information about the balances. So it's very important for this to be initiated from the beacon chain and translated into the execution chain. The way that this is done is via the engine API, which was truly tested for the merge, but now it will include also the information of the withdrawals. So this is something that needs to be tested very thoroughly, and all the interactions, but the engine API itself needs to be tested, and we are using various different methodologies to test this, using Hive, using the Testnets. And yeah, it's something that we really had to consider for this upgrade. As I already mentioned, both chains will have to activate their forks at the very same time. This required a lot of interoperability testing also, because you need to test that the beacon chain fully activates the fork and also the execution client. Which is a complicated thing to test, but for this we used also Hive. We used all kinds of different tests for this to be able to test this correctly. Also the state test, because we also have EVM upgrades into this fork. So yeah, we had to upgrade the way of the tool chain works for the state test, because we now have a new field on the block header. This is something that had to be tested and also implemented on all the tools, on all the testing frameworks that we have. And another thing is the complicated reorg scenarios that can happen. Reorgs on the beacon chain are something that is very, very unlikely. It's it's something that almost never happens, but still, this is something that needs to be thoroughly tested, because if a reorg happens for whatever reason during the fork, it is necessary to test that both chains, both clients are still in sync. And even if a fork happens, or a reorg, a smart reorg happens, we need to test those scenarios to make sure that everything keeps in sync and the consensus is not damaged because of any reorg that we could have. And yeah, similar to merge testing, we also have all the client combinations to be tested on DevNets, on Testnets, and on Hive. And this is something that was very challenging, and was challenging on the merge and still challenging today, because yeah, those combinations need to be properly tested. The tools that we are using are a wide range of tools. For example, we have the local Interop DevNets. This is something that also we have for the merge, and we are reproducing now. And it's very important because these are the first steps. The DevNets are always the first steps to test that the clients are following the spec correctly and have implemented everything correctly and can interact with each other. The shell forks is something that we also brought that started for happening at the merge, and we are also reusing it now to test naturally. But Parithosh will explain a little bit more about that. And Hive is one of the tools that has been very important to test in the merge and right now also. We have different suites of tests, either for only the execution clients or for the interoperability between the execution clients and the consensus clients, which is very important. And I will talk a little bit more about Hive in a bit. And also the spec tests. Yeah, this is something that we already have in place for the consensus spec tests. These are consensus layer client only tests, and these are really very special because they are generated using a Python framework that the consensus layer clients have. And I will talk a little bit more about this in a bit. We also have the original state tests, which is the entire set of tests that are used to test the consensus between the execution clients. The state test is a very big set of tests, and we keep adding tests to this. We have added tests for withdrawals and for all the EIPs, EVM enhancement that are included into this fork. We also have added a bunch of tests on the state tests. We also have a new kind of execution spec test, which is basically similar to state test, but is now Python based. It's like the next iteration that we want to also include into our tool set of tests. And yeah, eventually public testnets will happen. We'll upgrade before we have the mainnet upgrade, which is very important for us to test stability and all that. So yeah, the spec test, we have two flavors, as I already mentioned. Basically, the consensus spec test is a very special set of tests, because for the consensus layer, we have the entire spec is written in Python. So this allows the consensus test to be written alongside with the implementation of the consensus algorithm in general. So we have every fork in there. We have a long set of tests for the consensus clients, which are automatically generated for the consensus clients. And these are basically just files that are outputs to these Python scripts, and these are consumed by the consensus layer clients. And this help to test that the client has implemented the spec correctly. We also have the Python spec test for execution layer, which is kind of similar, but since we don't have the Python implementation yet for the execution clients, what we do is we have the Python tests which interact with one of the clients, and they between each other they are able to generate test pictures that can also be consumed by all the execution clients to make sure that their implementation is correct. And yeah, and I'm going to talk a little bit of Hive Tests. Hive is basically this interoperability tool that is used to test end-to-end testing between multiple clients at the same time. So there are a lot of advantages to this. Hive basically is a testnet that is very, very short-lived. But also, on top of being very short-lived, it's very deterministic on what it does. It does a very specific set of steps to reproduce not only the happy path test cases, but also very bad scenarios. So we have a range of tests. For example, we have a simple Shapella upgrade in Hive, where everything happens correctly and everything goes well. But we also have reorg tests, for example. If we can produce specific steps to produce a reorg exactly happening at the time of the fork. So this is very important because it helps to make reproducible scenarios that the client developers can use to not only find the bugs, but also test the fixes to this bugs that we find. So this is very, very important and is kind of different from testnets, but it's also very, very important to have this. And I have posted the link here. If the presentation is available after the presentation, we can you can go in. And basically, this is the list of all the test cases that we have that we currently have implemented, both for the engine API only, which is execution client only, and for the execution layer and consensus layer interoperability tests.
Cool. So I would continue. Thanks, Mario. So a couple of bigger points. So what we needed to first change for supporting testing to begin with for Shapella was we needed kind of two big things. First one was post-merge genesis. We wanted to be able to start all the clients such that the merge was already done. And the main reason for this is that the TTD merge transition tests are extremely hard to coordinate because you don't know how much difficulty is done. There's you have to set up like a proof of work chain, you have to set up a proof of stake chain, you have to merge it. And all of this has to happen before you can even actually start your tests, which at some point just becomes too tedious. So we wanted to be able to start such that the merge had already happened. And this also reflects more of how the mainnet is. We're never going to revert back to an unmerged state. So we might as well switch all of the testing such that it reflects how mainnet is today. So this took quite a bit of time in the initial months. We had to get support on every single client. We had to make sure that all the CLs and ELs worked together. So there was a decent bit of effort around DevCon to make this happen. And the second one that was missing was post-merge shadow forks. So we had this nice trick earlier that we used for shadow forks, which was when the consensus engine was changing from proof of work to proof of stake, we were kind of changing it into our own beacon chain rather than the main beacon chain. So that's how we achieved shadow forks. But the problem now is that the merge has happened. There's no transition anymore. So we couldn't do this switch. So we had to come up with a new way. I'll go into what the new way is in a couple of slides, but that was a bit tricky to build and test and actually come up with. So that was nice. So there's another testing suite that we hadn't spoken about earlier. It's called Kurtosis. Kurtosis is sort of like local testnets that anyone can run. You provide a JSON config that says, I want client ABC paired with each other. I want 4 of them with these genesis parameters, and then Kurtosis will just make it happen. The idea is that it only asserts the happy case. So we just use it to make sure that interop works. So typically when a client has a new image, etc., we could toss it in Kurtosis and make sure that, hey, at least we know that the image it works. The nice new thing is Kurtosis now has a Go library, so we could also write Go tests with it. So you can use it as just a Go test that spins up a testnet in the background. You can deploy your contracts in it. And if you can assert a certain condition, such as, did my contract break the network after X blocks? And if it fails, then you just get a failure on your Go test. So the nice thing is you can reuse a lot of the testing frameworks. We're still figuring out how to best use it, but then the ideal concept is that testnets become like a package. You can just import it into whichever package you want and then use it however you would like. So we're trying to do it with local testnets, with 4844, with withdrawal. So you have different test suites and all of them rely on like the same core Kurtosis package to start the testnet and run it through. Hopefully in like the next month or so, this starts getting more limelight and more usage. And the big one was the shadow forks. So now that we already have a merge chain, we had to figure out how to kind of fork that merge chain into our side chain, so to say. So the strategy we kind of settled down is spin up a bunch of, in this example, girly nodes. Wait until all the girly nodes are at the same head. Then we turn off the girly beacon node. And because the beacon node doesn't exist on our subset of nodes, it stalls our chain. They're all at the same head. They just can't progress. The EL doesn't know what to do. And then we query the latest block. And then we create a new beacon chain genesis that is built on top of this latest block. And then we start a new beacon chain on all of these nodes that kind of takes over. And because we base the genesis off of the state that the EL was already synced to, the EL will just follow. And in the meantime, the Gurley chain progresses as if nothing had happened, and our chain has basically forked off, and we control the validator set. And because we don't change the chain ID, we don't change anything about gossip, we don't change anything at that layer, we continue to stay paired with Gurley, and we continue importing transactions, we continue building blocks, we do everything. The only thing is we have now a divergent fork. We tried this a couple of times. The last attempt was actually today with Shapella, and all the clients are successfully able to shadow fork, and we were able to do a Shapella withdrawal shadow fork. So that works really, really nicely. Most of the tooling has also been updated, and I'll actually show you what tooling we used and how we've kind of organized things to make it a bit easier in the future for reuse, so to say. And yeah, we're going to be continuing to do a lot more shadow forks over the next couple of weeks. There's a mainnet shadow fork planned for next week. I'll show you the timeline before Shapella hits mainnet later on. So what users watch? This was also a bit of restructuring that we had to do over the last couple of months, and we're trying to follow this general pattern. So on the top layer, you have base CLI tools. They just do one thing. They do one thing really well. For example, ETH2val tools generates keys. ETH2 testnet genesis, give it configs, it generates a beacon chain genesis state. zCLI can parse the genesis state. Each of these are individual tools, most of them maintained by, I would say, Proto or a few other people. Jim maintains ETH2 and a lot of other tools. And the next layer are sort of packages or wrappers for these tools. So one example is we maintain the Ethereum Genesis generator, which just has some Python scripts to create EL Genesis files. It imports all the above mentioned base layer tools to generate CL Genesis files. And then there's just a bunch of bash scripts to parse what you want. That's pretty much it. Doesn't do anything else. You can start this as a Docker container. It opens a web port in case you want to fetch it over the network. Otherwise, it writes the file with a volume mount. It's really, really generic and can't really go wrong with it. We're using this with Kurtosis Tests, which I mentioned earlier was also a wrapper for, I want to testnet with this config, can you make it happen? And the same way, we have Ethereum Helm charts, which is, I have a Kubernetes cluster and I want these nodes, can you start it for me? So we have these two wrapper layers sort of. And then the next layer is the external reuse layer, so to say, or a deployment layer. And this includes consensus deployment Ansible that is a base level Ansible playbook system, role system that just tells you, I want a testnet, can you set it up? And then based on how you configure the variables, you get specific testnets. So what we've done for testing is we have this base thing and we just fork it. We forked it once for the merge testnets, we forked it for withdrawal testnets, Workle testnets, for 844, for Shandong. All of them reuse the same base Ansible playbooks. And we're trying in a future upgrade to make it even more modular. So we're taking the whole concept of Ethereum nodes out of Ansible and making its own collection. So you can reuse it as you want. We're just trying to make it another wrapper. So this is kind of the overview how we're going for. Every time, for example, if I had to give you the example of the next upgrade. So I forget the name, but it starts with a D. Let's just call it the next Ethereum upgrade. So we'd kind of start off at the base layer. We'd make sure that the Genesis configs there can be updated. Then we'd update the wrapper so that whatever wrapper values you have work. We'd fork the consensus deployment Ansible again. So you have, for example, 4844 testnet repo. And that 4844 testnet repo would have configs for specific testnets that we're doing. So in this like 2-3 steps, you kind of have this reusability as well as upgradability, and you can keep up with every testnet in the future without having to, start from the scratch and have to rework everything. And how did testing happen for Shapella? With a lot of effort. because what Shapella wasn't really clear until like a couple of weeks ago. So it is very hard to test something when you don't know what you're testing, and what you're testing has changing specs and changing client teams and changing requirements. It's a lot of moving pieces. So the way we kind of did this was with a lot of help and with a lot of parallelization. So the EOF testnets, for example, Shandong and all of its iterations were purely handled by the Ethereum JS team and G11 Tech. Amazing job there. They were doing all the outreach, they were doing the setup, they basically forked the consensus deployment Ansible. I helped them with the initial setup and then they just ran with it. The 4844 testnets have been taken care of by the guys from Consensus/Optimism and their DevOps teams. Done a phenomenal job with making sure. I think we've had 3 devnets so far, and we're slowly starting to help with perhaps the 4th devnet or with some Interop devnet, so we can also start getting our hands dirty for the next fork. And Barnabas from the DevOps team was working a lot on the withdrawals testnets. So we kind of kept these parallel testnet tracks that just enabled one specific feature. And then once we decided what was going into Shapella, we collapsed them into one testnet. And that's, I think, how we would also proceed in the future, just have parallel testnets with one specific feature. And then once there's more clarity from all core devs or whatever decision-making process, then we would just collapse them into one testing track to hit mainnet. I would like to think that some of the results of the testing went into framing what goes into Shapella. I think some of it does for sure, but you can never tell. Fuzzing found a lot of bugs between different client implementations and or spec changes. Huge shout out to Marius. We extensively use his TX fuzz tool that he keeps updated for every fork. I think even just last week it broke, it created bad blocks in DevNet 2, withdrawal DevNet 2. It's the one fuzzing tool, you just keep deploying it and it keeps throwing out bugs, which is awesome. And just a link of new-ish tools. Some of them have existed for a few months already, but I just wanted to highlight them as well. So we have a checkpoint sync provider, so checkpoint C. You might see that all over the internet when you're trying to sync testnet, or if you're trying to even sync mainnet nowadays. We have a metrics exporter. And we have a generic metrics exporter as well as an address tracker now. So if you want to run something locally that just gives you an alert when your balance is below a certain number, you can use our address metrics exporter now. It's all tying into Prometheus, Grafana, so it's just the base layer that we're iterating on. The Genesis generator tool that I mentioned earlier. So freely available, please PRs, fork it, use it however you like. We have our Ansible playbooks, and that's the one we fork for deploying all the testnets. And we are starting a new Ansible collection. And the idea of the collection is it can do one thing really well. And that one thing is I want a Lighthouse node, or I want a whatever node. And we're trying to kind of pull it out of consensus deployment Ansible so that we can have its own thing and use it in the future. And people can just fork it. You can use it for mainnet. You can use it wherever you want. And it's easier to set sane defaults when you have that separation. We have our Helm charts in case you're a Kubernetes house and you want to use those. We have the Go Kurtosis tests. Still needs a bit of work, but it's already at a place where people can think of using it. And we have a new project, which is a peer-to-peer monitor. It's called Satu. And the idea is you can have really simple nodes that are listening to P2P traffic and tries to pass them through a centralized database. And the idea why we wanted to have it is you can do some network level attestation, latency tracking, or some more bespoke things that maybe the researchers would like to have their hands on such data. So we're slowly prototyping that and figuring out what works and doesn't work there. So feel free to look out there. And yeah, huge shout out to the EIPs team. So Sam, Andrew, Raphael, Barnabas, and myself, all of us work on most of these tools. And yeah, that's feel free to fork anything or create issues whenever you want to. And now coming to the meat of it. So we started off with the Shandong testnet in October. That was largely EOF testnet. There was no withdrawals there. There was no, I don't even think it had some of the smaller EIPs that made it into Shapella now, but it was mainly EOF testing. And they got a lot of public eyes on it. A lot of bugs were found. People were really getting excited about what you can do with it. And the Ethereum JS team did a phenomenal job with that. And from then, there were a lot of local devnets that I won't even try and mention, where we were trying to figure out if post-merge Genesis can work, if post-merge Shadow Fox can work, or whatever actually Interop works, all of it. Then Barnabas set up withdrawal devnet 0 as well as 1. So both of these were the first iterations of the withdrawal testnets. We did not include EOF in them. It was purely withdrawals as a feature. I think by withdrawal devnet 1, we even had the small EIPs included, so limit, push 0, and init code limiting as well. And withdrawal devnet 2 happened, I think last week or the week before that, and that was promptly broken by TX Fuzz, if I'm not wrong, where Marius had this transaction that had caused some bad blocks to be produced, but thankfully everything was fixed and nice, and we sunsetted that. And there was a small minor spec change where we wanted to have the way to GUI change. And that was included along with the restart of withdrawal devnet 3. And that's the current state. We're planning withdrawal devnet 4 already potentially for next week. And we're thinking of doing something that's mainnet size, because we want to also try and see how it would work if so many BLS changes were submitted at the same time. Can nodes keep up? What type of cache would they need? How does that network actually look? And next week, there's also a mainnet shadow fork planned. So this would be a mainnet shadow fork 1. The nodes are already syncing and or already synced. It's there's a whole host of nodes there. And you might have noticed most of these were still devnets or testnets that you had to be quite technical to get into. And we want to try and offer something similar to how we had Kiln or Kintsugi over the merge testing efforts. So we call that Zhejiang. And this is more of a public testnet. So the idea is that it's it's useful for if you want to test out how your block explorers would look, or if you want to test out how your BLS credential change would look, or if you just want to figure out how withdrawals looks in general. The reason we chose the name is also it's a suburb of Shanghai, and it was also similar to how we chose the name for Shandong. And once that public testnet is out and has been successful for a while, we would hopefully move on to Sepolia, Gully. Definitely a lot of shadow forks in between, but that's when we start hitting public testnets, and hopefully we're on time for mainnet Q1 2023. So that's more or less how the timeline looks for testnets. And the generic question. One thing I have to mention, withdrawals doesn't really rhyme with urge, and we already have surge, verge, splurge, and so on. So Marius had the idea, we just shove it in there. I don't think anyone can ever say this, but you'll only ever see it on Twitter. If you have an alternate suggestion of how to make the term withdrawals rhyme with urge, please do let us know. We're happy to change the hashtag. Take part in the public testnets. We're hoping for some information over the next week, I'd say, or 2 weeks at the latest. Make deposits, withdraw, convert, tell us if you notice anything funky. Make sure your favorite explorers work. If you make a withdrawal and no explorer shows it, did you really make a withdrawal? Try everything out, and please write tutorials and guides. We definitely need people doing these things safely and in a relatively controlled environment. So we hopefully spend the next couple of months making this as nice a user experience for people as possible. And thank you. Join us in testing any of these feature sets and follow Mario and myself on Twitter. And thank you.
Superb talk. I mean, we learned about the activation process, challenges along with the other key features explained like really well. Sometimes it is hard to share the technical progress in simple English. As an Ethereum character, I think it is important to communicate it to the community where things are in the language that they would understand. So thank you both for all the efforts behind this presentation and of course, behind the testing that you guys are already doing. Well, at this point, we can go ahead with the questions which we have already collected from the community. So when we are talking about these DevNets, are they different on both an ELCL side, like how they are separate? And what is the plan to simulate the test to have the overall upgrade process done?
Yeah, maybe I can take this one. So we haven't done an EL specific or CL specific testnet at all. Since day one, it's been pretty much merged both EL and CL together. And we are mainly simulating the upgrade by actually setting the fork parameters. And then we're going through the fork and making sure that what we want to see on the other side is also what we see. So that's, I think, the two things there.
It is good to know, like with all those DevNets coming up in between, there were a bit of confusion, like what's going on EL side and what's going on CL side. So good to know that they were always in sync. Well, my next question is related to withdrawal. Of course, withdrawal is the center of the Shapella upgrade. You mentioned about DevNet 3 and like it has been recently launched. How do you think clients are performing there? There were a very few features which were expected to be changing from version 2 to version 3. So what are the key features and how are the clients performing there?
So the main feature change was, I think, the way to query change. Maybe Mario can talk about why that was an important change, and then I can proceed as to how the testnet went on.
Yeah, the important thing that happened here is that so basically the consensus layer and the execution layer do have different units when they store the balances of the accounts of the validators. And yeah, for example, the consensus layer clients, they all store the balance in Way, which is a different unit from Way, which is the base unit of the Ethereum accounts in general. So what's happening here is that we have the communication between the consensus layer that they want to, okay, increase the balance of this account in the execution layer by this amount. And the problem was that we wanted to have this same unit shared between the two. And originally, the unit used for this interaction between the consensus layer and the execution layer was Way, but it was just very recently changed to have the interaction and also the information stored also in the execution layer blockchain as Way. So this was a change that, yeah, there were a lot of changes in the tooling, in the different testnets, also in Hive, in the engine API. Everything changed just very recently. So yeah, it's the reason I would say is just to have the same format, because if we want to operate right now there was an issue, I think, because how the information was stored, and it was not coherent between the clients. So there were some ideas that the tools could have issues. So yeah, just standardize everything, have the same unit in both chains. That was the reason. Mm-hmm.
Yeah, and thankfully the change was not too bad. All the clients implemented it seemingly perfectly. We haven't had any real issues on DevNet 3. It's been quite stable. I think there was a couple of bad blocks produced by, I want to say Ethereum JS, but I think they already even found the bug and fixed it. So it was definitely not a critical issue there. It's been growing surprisingly smooth. So that's also why we kind of have the confidence to say, let's do DevNet 4 at mainnet scale, and let's do mainnet shadow fork already next week. Let's do more of these things that are stressing the clients. And these are not, let's just test if the feature works to begin with, because we tested withdrawals, it works on the DevNets. So we can stress them now.
I think confidence from testers gives a lot of confidence to the community overall. So yeah, thank you for answering that question. My next question is maybe a kind of follow-up with that. So recently we noticed substantial discussion on withdrawal commitment to better support light clients. What are your thoughts on that, and where we are on that? Like, are they included in V3, or do we have plans for have it in V4?
I think this was in relation to changing from root to SSE or something, right?
Yeah, I think so,
Okay,
because
okay.
there was a proposal to change from, we currently have the format that's just the RLP hash in the execution layer block headers. And there was a proposal to change that from that format to the format that is used on the consensus layer class, which is SSE. And yeah, that would have been a much bigger change. So I think it was decided on last All Devs that it was not going to be, or it wasn't followed. I'm not sure, but at the moment we have no implementations following that route. But
I think the main problem was also there wasn't an SSE library available for all the EL client teams to use immediately, at least not a well-tested one on all languages. I think it was soft agreed that this is something we would do next time, but I'm not sure if there's an EIP yet or how that's going to look.
Yeah, I think there's no EIP yet, and yeah, from what I understood from that discussion as well, it's a possibility in the future, but not right now. Yeah.
And it also seemed like there was strong interest in moving in that direction, but just didn't. I think no one wanted to hurry it and just push it. At this point, which is also a great sign, anything that is going to delay withdrawals is being taken a look at with like multiple microscopes, which is great, because that means everyone's committed to delivering withdrawals on time or not adding unnecessary delays to it.
Of course, at this point, if EL client team comes up with a new proposal, that would be a big challenge for everyone, including the client implementers and testing team. So good to know that there is a strong agreement in moving in this direction, but not having it considered for particularly this upgrade. Very well. My next question is about Shapella testing. So there was this discussion on the UX improvement of stakers like BLS to execution. Unsure if this has been resolved. Maybe if you would like to talk about the fork version gossip boundary issue and its inclusion in the testnet.
I think I can start with the UX issue. So basically, at the point of this, when the spec has started, there's a process that goes into the signature generation process that we have this BLS signature, which is signed with certain characteristics of the beacon chain, which includes the Genesis validator's root, but also the fork, the version of the fork. So the problem was that we were signing this BLS to execution changes with the head of the chain, which at the time was is going to be Shapella. But the problem was that when another fork occurred, these signatures would become invalid for this reason. And it was just recently decided, which I think is a great UX improvement, that it's not going to be signed with the Shapella fork, but instead it's going to be signed with the Genesis fork version. So this is a great UX improvement that just was recently decided and introduced into the changes. And this is going to allow all the stakers to just sign once and just do not worry about this signature ever again. They can just sign right now offline with their all the security measures that they have, and they can just broadcast the signature at any point in the future, which is great, I think.
Yeah, definitely. And I think the next point that was about how it's gossiped and when it's accepted to be gossiped, that's still an open discussion as far as I understand. But there's two large approaches. The first one is allow anyone to submit it before the fork happens, but it stays on your local node. It doesn't go anywhere else. And the moment the fork happens, then you start broadcasting these changes. And then the second approach is don't accept it at all until the fork happens, and then you start then you accept as well as immediately broadcast it. So there's some pros and cons for both of them. I think the first approach or the second approach might even want to add like a whitelist so that people aren't just spamming the entire any beacon node they see, they spam it with a change. The main reason this is even a thought is that when the beacon chain launched, the default credentials most of the stakers had was 0x0, which means they do not have, it's a BLS withdrawal address. It's not an ETH1 withdrawal address. But something like, I want to say a year in, it was added everywhere. So the staking deposits, CLI, etc. And a lot of people did set their ETH1 withdrawal address. So they have 0x01 addresses. And I think the split is something like 300,000-ish validators have 0x0 and 200,000-ish have 0x01. So of this 0x0, some people might have lost their keys. They might have lost their mnemonic, they might have had, something might have happened. So there's a lot of people who are desperate and a lot of hackers who are desperate to immediately get the change in, because this 0x0 to 0x1 is a one-time non-reversible change. So if the hacker gets their change in first, that's it's their withdrawal address. If you get your change in first, it's yours, which is, I think, why a lot of care is being given into thinking which is the best approach, such that nodes don't just blow up, or perhaps even having like a limited cache, or having a whitelisted address, or having, I'm not sure what the perfect strategy is, but I think that's the reasoning for whatever discussion is happening, or that's the context at least.
That is very interesting piece of information. And I know the gossiping is something that client devs may be able to take care of, but having this option available for seekers like to sign it offline is great to have. I hope we get that through and help people who have started it, like at the very beginning, as you mentioned, that may have lost it, get a solution to that. All right, my next question is about Engine API. So a few changes has been merged to Engine API recently, including unify failure mode for mismatch structure version and a bunch of cleanups. And I think in the last all core dev consensus call, a new change was suggested. Can you maybe talk a little bit about that, which is define payload bodies request and where we are with that?
Yeah, so yeah, basically this is a change to the Engine API. And as previous changes to the Engine API, this is one of the places where we are testing this is on the Hive test suite. At the moment, the focus is on the Engine API changes that are considered for interaction. For example, right now, the most important Engine API change that is tested on Hive is the one that controls the actual withdrawals between the two clients. And the rest of the changes are gradually being added. Before we are currently adding tests for all the changes. But yeah, basically this is a work in progress in this aspect of the Engine API tests. Mm-hmm.
Do we think addition of these small changes at this point of time may affect the timeline in any way?
Well, I think if it's a critical change, for example, if we're changing something inside of the main change of the communication with the CL or VL, yeah, that's definitely going to be push back to the probably next version of the Engine API. We have different versions for each of the methods that the Engine API has. We have version 1, version 2, for example, which one includes withdrawals, a newer one, and the other one doesn't. So in the future, it will be possible to just increase the version with new features. But I think at this point, I don't see the spec changing anymore with new additions. I wouldn't think that will happen at this point.
Yeah, I think if anything, it's just some small clarifications like when is gossip going to happen, etc., which wouldn't take most clients an entire sprint or something to implement, but rather maybe a few days. But yeah, besides that, I think it's just hardening and making sure that everyone has a production ready release.
Good to know that the people don't have to wait any further. It is going as per planned. Talking about plans, I know Interop testnet is planned and Interop sessions are going to be happening soon. Maybe if you can talk a little bit more about Interop session with respect to Shapella, like when it is, where it is, and what we are planning to test. the most over there?
Yeah, maybe I can talk about, I don't know about the where it is part, but the when it is like a focused interop, let's just say interop session over the whole next week, where a lot of client devs will be working on the Shapella upgrade, as well as on 4844 prototyping / interop. So on the Shapella track, we're going to see shadow forks. So the idea is that mainnet shadow fork 1 ideally happens on Monday already. And I think Marius already has some fun ideas for how to fuzz it and try to break it down. If it breaks down, we kind of have a backup idea that I actually don't know why we didn't necessarily try this before, but we want to just make backups of nodes once they're done, the mainnet nodes, and then just restore the backup so we don't have to bother fetching state from anywhere. We just kind of store the backup locally and then just erase everything. So we want to do that so that we could potentially do maybe 1 or 2 shadow forks, or maybe even 3 over the span of the week. It would be really easy once you have these backups to just keep reverting and going through the process all over again. So we want to try that next week for the Shapella track. And on the 4844 track, there is DevNet 4 that was planned to be released soon. That was at least a decision yesterday on the 4844 implementers call. And the idea there is to try and get as many clients as possible on that DevNet. They do have a new requirement. As far as I know, they will be starting at a Capella state. So similar to how we had to focus on getting all clients to support post-merge Genesis, they would have to start with post-Capella Genesis. And it's probably a really good idea to start doing that right now so that by the time it's probably mature, Capella would have hit mainnet. So it would be the most accurate way of testing. So yeah, there's hopefully a 4844 testnet people can interact with over maybe the end of next week, and there would be shadow forks people can see, and hopefully a public testnet that people can interact with immediately after interop.
So it's not a testing on vacation kind of Greece and Amsterdam event.
I don't think so.
All right.
Yeah, a lot of stuff to do.
Yeah, of course. I mean, we would like developers to get focused on testing and release of the mainnet, but at the same time, we want them to be sane as well. So a little bit vacation is also fine. All right. It's time to wrap up. Anything else that you would like to share with the Ethereum community?
Feel free to join us in testing withdrawals. First step, find a new hashtag, or really make this hashtag big. Whichever one. You can't start testing anything without a hashtag. That's the biggest blocker. So please help us.
Yeah, also join the public testnets. It's amazing that people can join and just test everything with us at the same time. So yes, everyone's very welcome to join and send their withdrawals to the validators on the testnet, right? The test validators. So yeah, it's gonna be amazing.
Those are some encouraging words. I hope many people join us for testing. Parithosh and Mario, we appreciate you taking out time to talk about testing and tooling part of the upcoming upgrade and sharing the roadmap. I hope this is comforting for people eagerly waiting to see the upgrade activated on the mainnet. On this note, thanks to our channel subscriber for watching and listening to this special episode on Shapella upgrade. Check out description for Shanghai Capella playlist to follow other EIPs and related talk on this upgrade. Should you have any question on this or any other proposal, let us know at eCatHurdles Discord. Ethereum Cat Hurdles are collecting user suggestions for client improvement. If you run an Ethereum node, please take out time to share your response, make your voice heard to the client development team. Link is available in the description. Next week, we will be back with another interesting talk. Till then, keep watching, keep listening to Ethereum Cat Hurdles PEEPanEIP show. Thank you, everyone. Cheers.